Okay, so today we will start with the binomial theorem. Anyone of you know about the binomial theorem? What exactly is binomial theorem?
Somewhat. X squared plus bx plus c equal to 0 is a binomial equation.
That is a different thing. Okay. So before understand, we just need to have some intuition out of binomial theorem, because that you don't need to know all things about the binomial theorem. So to build that idea, first let's start with the basic one. Let's suppose we have a plus b square. What will be the, if we open this came out to be a square plus 2ab plus b square, right?
Right.
Okay, unfortunately I forgot to do this. Okay, now
Okay, got
if
it.
I take the cube of this, you don't right now, you don't need to know the formula. I'm just writing the form to give you an idea of something. That will be a cube plus 3a square b plus 3ab square plus b cube, right? And this will goes
Yes.
on and on. So if I make the generalized formula, that is something like an plus n minus 1 into b plus something, and at last there will be b power n, right? If you see closely, we have a plus b square, right? The first term and the first term. The first term is present in all of these except the last term. Likewise, a is a factor here, here, but not here. And if you open this a plus b to power n, all of these will have a in them except the last one. Getting my point? I will give you example why I'm doing this. I will repeat that.
Yes.
Whatever the first value is, for time being, if this is a is present all of these except the last value and last value, right? Let's suppose if I give you an ask you to solve a question, and the question is like, what is the reminder? When 2 power 66 is divided by 9. So the question is, what is the reminder when 2 power 66 is divided by 9?
One.
Okay, so how do you solve this question? There are usually two methods to solve this question. More than two, but we will consider on two methods. One method is by seeing the cyclicity, just see the last digit, but we will not do that method. We will try to solve this using the binomial theorem, right? Now we have 9 in the denominator. We will try to have 9 in some way in the numerator. How can we do that? What is the closest? Okay, if I do this way, this is 2 power 3 and this is 22, right? This is the same thing what I did. I'm audible?
Yes, you are.
Yes, you are.
I can write 2 power 66 as 2 power 3 whole power 22. I can write this way, right?
Yes.
So this is 8 into power 22 over 9, right?
Yes.
Now can I write this as 9 minus
9.
1, 22 over 9?
Yes.
Right?
Can.
Isn't this similar to the binomial theorem? Doesn't
Yes.
matter whether it's positive or negative. You will see that, right? Now we have 9 in front, right? If I open these, all of the first values have some factor 9 in that, except the last value. Whatever the last value,
minus
with the
1
sign minus 1 power 22
to the power 22.
divided by
That
9,
means
right? All of these have 9, value of 9 in there, some value of 9 in there, some value 9, except the last one, right? If I divide by 9, the remainder for this is 0, the remainders for this is 0, the remainder for this is 0, for this is 0, and we are left with minus 1 power 22 over 9. I told you already that when we have a negative value and we take the even power, the result is always positive, right? So minus 1 power 22 came out to be plus 1 divided by 9. So what is the remainder in this case?
1.
1.
Right? So there could be a case, for example, we have a negative 1 and the power, let's suppose 23. So the
Minus
result
1.
will be minus 1 over 9. What will we do now?
Remainder.
This is
If
the concept of the negative remainder. We will just add, actually this is dividend and this is divisor, right? We will just add divisor in the upper value. Divisor is 9 plus 9. This came out to be 8 over 9. So our remainder is 8 in that case. So whenever we have a negative
How?
value, just add divisor in that. Divisor in 9. So result came out to be 8 over 9. Just remember this thing, whenever we have a negative value in denominator while solving the remainder question in the numerator, just add whatever we have in denominator in the upper side. Minus 1 plus 9 divided by 9 is equal to 8 over 9. So our remainder in that case is 8. Got my point?
Yes.
Can you please repeat it again?
I just said that this is actually a concept, or the concept is like, let's suppose we have B and A, and we have some remainder R. So in this case, we have positive remainder R, but likewise, there exists a negative remainder that is R minus A. This is negative remainder. This is extremely helpful when we are dealing with the bigger values. I will solve the question when we move to the negative remainder. Only the point is that this could be positive and this could be negative. If you just add again A in this is R minus A plus A, the result will be only remainder, which is what we did here, right above. We have minus 1 over 9, just add 9 in that came out to be 8 over 9, and 8 is our remainder, right?
No, I have a doubt.
Yes.
When you divide a negative number, there also you keep the remainder positive, or there can be negative.
Repeat your point, what you are saying.
So, so suppose we are trying to divide 64 by 9, minus 64 by 9.
Minus 64 by 9.
Yeah. So here you will try to keep the remainder
Just
as
keep
negative.
doing this. No, just keep adding 9 in this until you get a value less than 9.
Okay.
Right? Though you never get this much value, that value, just we will solve a question when we will move to the negative remainder part. Just keep this question with you, right? Let's first take 2-3 example for this binomial theorem, then we'll move forward, right? Okay, so let's have another question, another basic question. What will be remainder when 2 power 69 is divided by 9? Just take 1 minute to solve this question. What is the remainder when 2 power 69 is divided by 9? Binomial theorem. Try to solve using binomial theorem.
Eight.
Obviously 8.
Yes, exactly 8.
8.
The point is, whatever you make in the upper side, try to have some multiple of 9 on the upper side, right? So we have 2 power 3 and the upper thing is 23, right? So this is 8, 23 over 9. We can write this as 9 minus 1, 23 by 9. And if you proceed further, you will get whatever the value is still minus 1 power 23 by 9. So you have minus 1 over 9 and end result minus 1 plus 9 over 9, which is 8 over 9, right? Isn't this a easy method to solve this question?
Yes.
You can also use cyclicity, but that will take time to solve. I will suggest you try to solve whatever the question you got of this type using this binomial theorem. Just another question.
Can you explain that 8 raised to 23 by 9, that's equal to 9 minus 1? After that, how you done?
9 minus 1 over 9.
That is clear. The next step.
This step,
Yes.
I just have to move back to the from where we started.
I joined late.
Okay. Okay. Let's be quick. Let's suppose we have a plus b square. This is a square plus 2ab plus b square, right? And if we have a plus b cube, we have a cube plus 3a square b plus 3ab square plus b cube. So if we proceed and try to make a generalized formula, this is something like that. The only point is we have a, whatever the first value it, all of these have a in this except the last one. Likewise, a in this, a in this, a in this, and no a in this. And if we extend this formula, all of these values have a in that except the last value. So the point is, if you divide this by a, all of these have remainder 0 except the last value. Likewise, remainder for this is 0 except the last value. And exactly this concept is, this is a concept we are using here, right? If you open this, you have 9 minus 1 power 23 over 9. If you open this, all of the first values have 9 in that, except the last value, which is minus 1 power 23. If you divide that by 9, because all of these have 9, the remainder will be 0. All of these have 0 remainder. And the last came out to be minus 1 power 23 by 9. And negative value, power odd, always result in a negative value. So minus 1 by 9. Now this is a negative remainder concept. Whenever you get a negative dividend, just add divisor in that. We have 9 divisor. So the result came out to be 8 over 9. And our dividend is less than divisor. So that is our remainder. Got the point?
Yes, yes.
Okay, so quickly one more question for this. Okay, the question is, what is a remainder when 51 power 25 is divided by 13? Exactly, what is a remainder when 51 power 25 is divided by 13? You have just 1 minute to solve this question.
Well,
12.
Okay, so one answer is 12. Any other answer? Anyone is still solving, or shall I solve this now?
It's 12. I've got 12.
Yes, 12 is the answer. Just solve this quickly now. We have 51. So what is the closest multiple of 13 closer to 51? That is 52, right? So 51 will be 52 minus 1 power 25 divided by 13. Now this value is a multiple of 13, right? So all of the first values will be a multiple of 13 except the last, which is minus 1 over 25 over 13. So this is negative power odd. The result is negative -1 by 13. And again, using a concept of the negative remainder, 1 plus 13 by 13, this came out to be 12 by 13. And our remainder is 12. Everyone got this?
Yes.
Yes, yes.
Okay, so one last question relevant to this. The question is, what is the remainder when 2 power 100 is divided by 12? Solve this question now. When 2 power 100 is divided by 12.
Ten.
10. Okay, any other answer?
Four.
Four.
Any other answer? Are anyone still solving, or shall I solve this now?
Four.
Yes, 4 is the answer. Now, one way is from which we discussed earlier. But in some questions, you can use cyclicity. Like if I try to solve this question, but we have 2 power 1 divided by 12 is 2 by 12, remainder is 2. But we have 2 square over 12, this is 4 by 12, remainder is 4. 2 power q by 12, 8 by 12, the remainder is 8. Now 2 power 4 by 12, this is 16 by 12, the remainder is 4. 2 power 5 by 12, the remainder is 8. Now just leave this. After this, there is a cyclicity of 4 and 8. 4 and 8 is repeated in every pattern. For even power, the remainder will always be 8. And for odd power, remainder will always be 8. Right? We have even power, 2 power 100. And divide this by 12, the remainder is always 4. So the use of method will depend from question to question. I even got this, and I am now moving to the old method to be discussed. Shall I move to the old method? I even got this, what I did here.
I mean, in this question, 2 raised to 100. So you have used 2 raised to 2 by 12, that one, right?
2 raised to, I don't get you what you are saying.
I mean, till 2 raised to 5 by 12, the remainder is 8. Till that I'm clear.
Yeah,
Then
afterward,
how
if
you
you
go-
proceed further, if you take 2 power 6 by 12, again the remainder will be 4. So after first one, ignore this. After first one, you will always get a pattern of 4, 8, 4, 8, 4, 8. So for even power of 2, the result is 4. And for odd power of 2, result is 8. And our question is saying that we have even power, which is 100. So that's why our result is 4. This is from cyclicity.
Okay, okay.
Now let's solve from the method from which we are doing earlier. We have 2 power 100 divided by 12. Okay, so there are several ways. I will do this way, that we can write this as 2 power 4 into 25 by 12. Nothing wrong in this, right? So this is 16 power 25 by 12, right? I can write this as 12 plus 4 power 25 by 12, right? Now, again, from the method we did, this came out to be 4 power 25 by 12. And after this, we will move to the 4 power 25 by 12, right? Again, by using this is, if I write this way, 4 power 1 into 4 power 24 over 12. This is just the concept of the exponents, that when the bases are same, the power is added, right? So I can write 4 power 25 as 4 into 4 power 1 into 4 power 24. Nothing wrong in this, right? Okay, so 4 into 4 power, we can add 4 square into 12 divided by 12, right? So this again came out to be 4 into 16 power 12 by 12, right? Am I doing right till now? Okay, so this is 4 into 12 plus 4 power 12 over 12, right? So this came out to be 4 into 4 power 12 over 12. Again, just quickly doing that way, this came out to be 4 into 4 square over 6 divided by 12. And if I start doing this, this is a big lengthy. That's why I told you earlier that for this question, better to use cyclicity. And again, this came out to be, in the end, this came out to be 12 plus 4 power 6 over 12. And this, if we move further, this is 4 into 4 power 6 over 12. And moving forward, this will be 4 into, again, 16 plus 4 into 4 power 6, right? So 4, 2 into 3 over 12. This is 4 into 12 plus 4, 3 by 12. And this will be 4 into 4 power 3 by 12. This is 4 power 4 by 12, right? Which is 4 square power square over 12. But I'm already done this question. And last, this is 4 square by 12, and 4 square is 16 over 12, and now the remainder is 4. That's why I told you earlier, for this question, try to use cyclicity. The uses of method will depend from question to question. Got this method, what I did here?
Can you just quickly explain cyclicity method once more, please?
The cyclicity method is, okay. So when you have 2 power 1 and divide by 12, what is the remainder? 2. When you have 2 square 4, the remainder is 4. For 2 power 1, remainder is 2. For 2 power 2, remainder is 4. For 2 power 3, remainder is 8. After these, there is next is remainder is 4, then remainder is 5. If you proceed forward, the remainder is 4. Then again, remainder is 5. Remainder is 8. So the takeaways from this is, ignore this, right? After this, there is a pattern 4, 8, 4, 8, 4, 8. So for every even power of 2, the remainder is 4. And for every odd power, the remainder is 8, right? Now, if you move to the question, you have 2 power 100 over 12. This is even power, and divided by 12 will always give a remainder of 4. Got my point?
Yes, got it. Thank you.
But in exam, most of the question won't be this much lengthy. Most of the question could be solved with the binomial theorem very quickly instead of going with a cyclicity, right? So better practice cyclicity and this in combined. Okay, now let's move to the negative remainder concept, right? Okay, so let's suppose if I say that we have 10 and divide by 2. So if we take 2, this is 8 and remainder is 2, right? For this, the positive remainder is 2. But for this, negative remainder will be 2 minus 4, which is minus 2. Minus 2 will be negative remainder. Now let's see where is the use of this negative remainder. For example, we have a question, very simple question. The question is, what is the remainder when 129 into 130 into 131 is divided by 11. Just try to solve this question without using calculator. You have just 1 minute to solve this question. What is the remainder when this 129 into 130 into 131 is divided by 11? Just solve this now.
Five.
Okay, you are saying 5.
Yeah.
Any other now? Okay. Anyone still solving or shall I solve now? What is the answer? 9?
9.
Okay. So we have 5 and 9. Any other answer? Okay. The question is, we have 129 into 130 into 131 divided by 11. So what is the closest multiple of 11 less than 129? That is 121, 11 into 11.
121.
So 121 plus 8 into 121 plus 9 into 121 plus 10 over 11, right? Now, if I divide this, for remainder for this is 0, remainder for this is 0, remainder for this 0, we are left with 8 into 9 into 10 over 11, right? Now just multiply above those, all of these, and this came out to be 720 over 9 over 11. And if you proceed further, so the lowest multiple of 11, this is 65 into 11 plus 5 by 11. This for this remainder is 0, and the result came out to be 5 by 11, and hence the remainder is 5. Everyone is comfortable with this conventional method?
Please describe once. I haven't got it. 72 by 11. I haven't got it from that point.
This is 720
Yes.
over 11, right? So what is the multiple of 11 less than 720?
It should be 66, right?
66.
11 times 6 is 66. So
It's 726.
Oh, sorry. I didn't add.
72, it's 720. 66, how can it be?
Is this 720? 8 into 9 to 10.
Yes.
Yes.
Right? So the lowest multiple of 11 less than 720 is 715. We can write this as 715 plus 5 over 11. Right? So this is a multiple of 11. That's why for this remainder is 0. And the result came out to be 5 over 11. And which is our remainder.
No,
Right?
I got it, but the previous portion I didn't get it. That means 65a into 11, how it became, I didn't get it.
Listen, this is 720. We can write 720 as 715 plus 5. Right?
I got it,
And
but the
715 is just 65 into 11 plus
okay.
5. This is what I write there. Now let's move to the negative remainder concept. We have 129 into 130 into 131 divided by 11. What is the multiple of 11 greater than 129? That is 132. We can write this as 132 minus 3 into 132 minus 2 and 132 minus 1, right? There's nothing wrong in that, right? Now, if I divide with 11, this is multiple of 11, remainder is 0, remainder is 0, remainder is 0. We are left with minus 3 into minus 2 into minus 1 over 11. If you multiply this, minus into minus plus plus into minus 1 is negative. So this is minus 6 by 11, right? Now, this is negative value. Just add 11 in this. This will become
5.
minus 6 plus 11 over 11, and this is 5 by 11. Isn't this a quick method in comparison with the conventional method?
Yes, it is effective.
Yes.
Now, quick, one more question relevant to this. For example,
How can we? I'm a little bit confused. How can we segregate that? We have to use conventional method, or we have to use negative
it depends.
remainder method.
Whenever you have a very bigger values, let me show you one more question just like this. Let's suppose we have 1555 into 1557 into 1559 divided by 13. If you start solving this using the conventional method, that will take a lot of your time. Try to use negative theorem concept whenever you have a bigger values. Now let's see what is the multiple of 13 greater than 155.
120.
That is 1560, right? So 1560 minus 5. Right? Next one is 1560 minus 3 and 1560 minus 1 divided by 13. These are multiple of 13. So result came out to be minus 5 into minus 3 into minus 1 divided by 13. Now this is minus 15 by 13, right? This is the question what someone exactly asked me earlier, that in negative this is bigger. Now just add 13 in this. This came out to be minus 2 by 13. Just again add 13 in the above value. This will came out to be 11 by 13. And now the remainder is 11. I got the point.
Yes,
So
got it.
is it always like the negative remainder is a shorter process and a quicker process? Am I right?
Yes,
Or is
yes.
it my
Most of the question, in most of the question. Just remember,
Even
try to use
we
this.
add 13 double
Yes.
times? Yes, it's still
Yes,
much
because
easier.
yes. The only
Thank
point
you.
is that
Thank you. Very great trick.
whenever you have a value in absolute term greater than the denominator or divisor with a negative, you will have to use the divisor multiple times. But in comparison, this is way quicker method. If you start using a conventional method in this question, you will first have to see what is smaller, then you will multiply, then again you will multiply. And in the result, you will get some answer, whatever the answer is, right? So whenever you have a bigger values, try to go for the negative remainder term. Okay.
Even for the smaller values, this method
Yes, you can
is
use
way
that.
easier.
For example, just give me some example. Any example from your side? Okay, the session is again about to end. Just join the session again. We will start from where we left. Now let's move to the successive reminders. Successive division, sorry. So what exactly is the successive division concept? in successive division, there is only one minute difference. Let's suppose if there is a question, I am giving a question. The question is a number 1 divided by.
What is successive division?
Let me show a question, then we will discuss this. A number 1 divided successively by 4 and 5 leaves a remainder 1 and 4 respectively. What is the remainder? When that number is divided by 12. Divided by 20, not 12. Okay, solve this question.
9.
9? No.
Yeah, no.
Actually, the concept of successive division is that in this question, we have a number. When that is divided by 4, the remainder is 1. Let's suppose the number is n. When divided by 4, the remainder is 1. For time being, consider the quotient is a. Now, first of all, we are given that they are divided successively, right? If the same number is divided by 5, the remainder is 4. But in successive division, when you do first division, for second division, you will use the quotient of first division, which is a. Now, if you divide this quotient by 5, the remainder is 4.
I got the remainder 4.
The remainder answer is not 4. In successive division, the only point is, in first division, that is normal. For second subdivision, you take the quotient of first and proceed the way. At earlier, but without successive division, we just consider again this one as n 5 over 4 and whatever the quotient is, right? But in successive division, in second division, you will just consider the quotient of first division, right? So as per this question, if I form the equation of this is 4a plus 1 is equal to n, and equation for this is 5b plus 4 is equal to a. If I substitute a in this will came out to be 4 into 5b plus 4 plus 1 is equal to n. This is 20b plus 16 plus 1 is equal to n, and n is equal to 20b plus 17. Now, if we divide this by 20, this is multiple of 20, remainder is 0. And for this, 17 over 20, remainder is 17. Right? So in successive division, first division is same as this. And for second division, just take the quotient of first and proceed further. In GRE, this is a very rare type question. In GRE, if this is the case, you always have to do till 2 or 3, not more than that. But in actual, you will keep moving unless your quotient becomes 0. So that is not the case in GRE. Okay, let's have one more question. You will get exactly what I'm saying. For example, the question is, a number when divided by 5 and 2 successively, divided successively by 5 and 2, it gives remainder 3 and 1 respectively, 3 for 5 and 1 for 2. The question is, what is the remainder when the largest 2-digit such number is divided by 12? Solve this question now. I repeat the question. A number when divided successively by 5 and 2, it gives remainder 3 and 1 respectively. What is the remainder when the largest two-digit such number is divided by 12? Solve this question now.
Is the answer 6?
Okay, so one answer is 6. Please mute yourself, whoever is just making noise. Please mute yourself. Okay, one answer is 2. Any other answer?
Eight.
Please mute yourself. Who were this guy? Let me see who is this.
8.
Okay, so one answer is 8.
I've got 2.
Yeah, there are 2 2s, right? Okay, so answer to this question is 2. The question says that successive division, right? When number is divided by 5, the remainder is 3. Let's suppose the number is n. When divided by 5, the remainder is 3. And let's suppose the quotient is a. And after successive division, when it divided by 2, the remainder is 1, right? And if you take quotient of this and divide by 2, the remainder is 1. So let's consider quotient for this as b. So for first, 5a plus 3 is equal to n. For second, 2b plus 1 is equal to a. Just substitute a in this. This came out to be 5 into 2b plus 1 plus 3 is equal to n. This is 10b plus 5 plus 3 is equal to n. This will become 10b plus 8 is equal to n. Right? Now the question is, which are the following, what is the largest two-digit number, right? Asking for reminder when the largest two-digit number is divided by 12. So from this, what will be the largest two-digit? When b is 9, this will become 90 plus 8. In that case, n is 98, which is the largest two-digit number. And if we divide this by 12, so this will be 96 plus 2 by 12. And 96 is a multiple of 12. So remainder for this is 0. And the answer came out to be 2 by 12. And 2 is our remainder. So whenever you are solving this question, just keep an eye on the word, whether that is successive division or the normal division. All right.
I didn't get it from how did you put b equals to 9?
Listen, the question says that what is the remainder when the largest such two-digit number, and the question is largest two-digit number. So tell me the case when we are having the largest two-digit number out of this. Substitute any value of b. The only possible largest possible two-number digit is when b is 9. If you substitute b as at 8, this will become 88. For 7, 78. But for 9, this is 98. After 9, this will become 108, three-digit number. So the largest two-digit number is 98.
Okay, got it.
Okay, so we have covered all the remainder portion. Let me give you the two questions that how the remainder question is usually asked in the what problem format. Okay. So the question is, okay, let me move to the first slide. Very interesting, two very interesting questions. And this is usually the way the remainder questions are asked in exam. For example, the question is, club X has more than 10.
What have you written? Start. What is the
Sorry,
first
club
word?
Club X. Any club, just consider club X has
Okay.
more than 10, but fewer than, less than 40 members. Okay, Afterwards,
You're
sometime
not clearly audible.
I'm not audible.
Not clearly.
Sometimes it's lagging.
For timing, is am I clearly audible or not?
You're audible to me.
Yeah, audible.
Club X,
Audible.
Club X has
Audible.
Club X. Okay. Club X has more than 10 but fewer than 40 members. Sometime the members sit at a table with 3 members at one table and 4 at each of the other table. Right? Sometimes the members sit at table with 3 members at one table and 4 at each of the other table. And sometimes they sit at table with 3 members at one and 5 at each of the other table. Okay, the question is, if they sit at table with 6 members at each table except the one having fewer than 6. The question is, how many members will be at the table which is fewer than 6? At fewer than 6 one. I repeat the question. Club X has more than 10 but fewer than 40 members. Sometimes the members sit at at a table with 3 members at one table and 4 at each of the other table. And sometimes they sit at table with 3 members at one and 5 at each of the other table. If they sit at table with 6 members at one table, except the one having fewer than 6, how many members will sit at fewer than 6 members of the table? Solve this question. Everyone got this question?
Yes.
The last part is, how many members will be at the table that has fewer than 6 members? Right? Just solve this question.
5.
Yes.
5.
Okay. Anyone else? This is the actual way how most probably in harder part the reminder question is asked. The way how the reminder question is asked. This is simply the simple question that how we discuss, but this is asked in a verbose way, right? In a verbal way. Just take 1.5 minutes to try to solve this question. Okay, so anyone you got solved this, or anyone who is still solving? Okay, let me solve this question now. The question was like, Club X says, first of all, members, let's suppose the total members are M and that are between 10 and 40, right? The question was greater than 10 but less than 40. And the next is, okay, fine. And the next is, okay, whenever they sit at the table with 3 members at one and 4 at each of the other. So first of all, if they sit at all of the table at 4, but in one table, they are left with 3, right? Got this, how I form this? Because if the member sit at all of the tables having 4 members, there's only one table left which has 3 members, right? Likewise, the question said afterward that, okay, so where were we? Okay, again at 5 at each of the other and 3 member at one, right? Now, if they said 5 at each of the other and 3 member at one, let this quotient as A and the quotient as B, right? So first one will be 4A plus 3 is equal to M, and second will be 5B plus 3 is equal to M. Now you can do by the method which I discussed in the yesterday session, but for this I will quickly use the even and odd. This is even, this is odd, the result is odd. How can I get a result of odd? This is already odd, so this has to be even. This is even when this is B is 0, B is 2, B is 4, up to so on. When B is 0, first term is 3. When B is 2, second term is 3, 23, 33, and 43. I quickly filter out this and this because the question given is that the members are between 10 and 40, right? So if I see 13, 4A plus 3 is equal to 13. No, this will not be an integer value. Next one is 4A plus 3 is equal to 23. So this will be 4A is equal to 20 and A is equal to 5. So they are total 23 members. If we divide 23 by 4, the remainder is 3. When divide 23 by 5, the remainder is 3. Now the question was, you have total 23 members and all of them will sit at the table with 6 members except the one, right? So if you divide 23 by 6, what will be the remainder? It will be 5. So the last table will have 5 members sitting in that. Is this question understood by all?
No,
From where?
No.
I don't know. This question is very complicated. I didn't even understand the question itself.
Listen. I repeat the question. There is some sort of club having members between 10 and 40. First of all, the members are between 10 and 40. First thing first. Afterward, they said that sometimes the members sit at a table with 3 members at one and 4 at each of the other. So this means if all of the members are sitting in a table having 4 member capacity, so there's only 3 members left, right? So for those 3 members, there will be a table with the 3 members. Total member when divided by 4, the remainder is 3. This is first situation. For second situation, the question said that if all of them sit with 5 members, and the question is, and sometimes they sit at table with 3 members at one. This is the clue. At one and 5 at each of the other table. Now, if those members, all of these sit at 5, so there only one table left in which there are only 3 members, right? Got till now?
Yes.
Now just make the equation and solve whatever way, either by substituting or either even or. This is just the way we did yesterday, right? So no confusion how I come with 5, not 5, how I just form the equation and get 23 first. I believe there's no confusion in that.
Yes, but can you solve it through substituting method?
Okay, so we have 4A plus 3 is equal to m, and 5b plus 3 is equal to m. So when a is 0, this is 3. When a is 1, this is 7. When a is 2, this is 11, right? Okay, when a is 4, this is not 4, 1, 2. When a is 3, this is 15, gap of 4, right? 15, then 19, then 23, then 27, then 31, up to so on. And for the right word, this is 3 when b is 0, then 8, 13, 20, 18, 23, 28, up to so on. The first common term in both is 23. So it doesn't matter, because the question says that the numbers are between 10 and 40 and our value is between this, right? So just divide 23 by, and the question at last say that if they sit at the tables at 6 members each, except the one having fewer than 6. Now, if we divide this 23 by 6, if all of them want to sit at a table with 6 members, then how much will sit on the table with less than 6 members? If we multiply this by 3, this is 18, and the remainder came out to be 5. Got this question now?
Yes, thank you so much.
Yes.
There's last question, but even that is way verbose than this.
Does this sort of questions appear in GRE?
Yes,
Because
yes.
these are very complicated.
This is not complicated. This is just exactly what we did, but it is written in, this is just in written form. At first, we are just given the 1 or 2 statement. But remember one thing, in exam, even sometime you could have a question of length from 8 to 10 lines. So be prepared. The exam is highly verbose, not just like x plus y, whatever the question is, that is not always in written in the expression form. Sometimes you in word problems, you have to make your own expression and then proceed. And most of the word problem is the highest percentage question. Most of the concepts are tested through word problems in written form, right? And for last question, I'm just skipping the whole of the scenario and just asking you that in a school auditorium, students are to sit in some sort of arrangement. If all of the students, okay, let me just quickly write down. If students sit in a row of 16, 12 students will left out. If they sit in a row of 24, 20 students will left out. If they sit in row of 25, 21 students will left out. And if they sit in row of 30, 26 students will left out. So the question is, what is the minimum number of students present in the school? I repeat the question. There is some sort of auditorium in which students are to be sit down. And if all of the students are asked to sit in a row with a 16 student each, there's only 12 students left out. A row with a 24 student, 20 will left out. Row with a 25 student, 21 will left out. And row with a 30 student, 26 will left out. So the question is, what is the minimum number of students in that auditorium? Indirectly, what is the minimum value of n? From this, just solve for the minimum value of n. Try to solve this question. This is exactly old question, but there are 2 more. At first, we are just dealing with 2, but now we have to deal with 4. Just try to solve this now.
Question is what?
What you are saying?
Question is what? The final question.
What is the minimum value of n?
Was there any sort of range given?
No. The question is, what is the minimum value of n? Just try to solve this question. This is a very interesting question. Okay, let me solve this question now. We have 4 scenarios, right? If that is divided by 16, remainder is 12. Let question be A, B, C, and D, right? And try to make 4 equations.
Can I guess the procedure regarding this?
Repeat your point, what you're saying.
Can I guess the procedure regarding this?
Procedure? You want to tell the procedure?
Yeah, I haven't got answer, but I think this might be the procedure regarding this.
Okay, so what's the procedure?
Okay, as we have 4 opinions. First is 16a plus 12, while second is 24b plus 20. Here both we have got even in both case, first and second case. Likewise, in fourth case we have got even 2, 30d plus 26. We have got even 2. In third case we have got 25c plus 20, and here is odd.
Okay.
Can you solve in this scenario like this?
Okay. Listen. Let's see how I solve this question.
But n is even for all, because when I made the equation, so n is even for all.
Okay, first equation is 16a plus 12 is equal to n, right? Second one is 24b plus 20 is equal to n. Third one is 25c plus 21 is equal to n. And last one is 30d plus 26 is equal to n. Now let's try to alter these to get some common form in these. Let's suppose, because if I do this way, this is 16a plus 12. If I add and subtract 4 this from this, doesn't matter, because I'm just trying to make some form out of this, right? I'm just add and subtract 4 from this, right? So this will become 16a plus 16 minus 4 is equal to n, right? Asking about first one. So we can add this as 16 into a plus 1 is equal to n plus 4, first form, right? You got what I did here?
No.
I just add 4.
Yes,
I just add 4 and subtract 4. That will make no change, because 4 and 4 will cancel out. The result will be same. But just I'm trying to make some form out of this. Now, if I do for same for second, this is 24b plus 20 plus 4 minus 4 is equal to n. And this is 24b plus 1 is equal to n plus 4. Right? For third one, this if came, I'm just moving now. This came out to be 25c plus 1 is equal to n plus 4, right? And for last one, if I do same, this came out to be 30 into d plus 1 is equal to n plus 4, right? right? So first of all, the thing is, we have 16, 24, 25, and 30. Whatever the value is, that must be a multiple of all of these. So what is the lowest multiple of these? That will be the LCM all of these. So what is the LCM of 16, 24, 25, and 30? LCM of 16, 24, 25, and 30. This is 2 power 4. This is into 3. This is 5 square. This is 2 into 5 into 3. Right? So what will be the LCM? 2 power 4 into 3 into 5 square. Right? This is, I believe, 1200, right? Is this 1200?
Yeah.
Okay. So this is 1200. So the LCM of all of these is 1200. So minimum value is 1200, and the right side, all of these are n plus 4. Now equating this with n plus 4 and came out to be minimum 1200 minus 4, which is 1196. Got my point?
Yes, got it.
I just want to show you the way that at first we are just doing for 2 equation. There could be a scenario that they give more than 2. So how do you proceed in that case? Remember, in exam, if the question seems difficult, there'll always be a pattern for that. Just like in this question, there is a pattern of 4. 4 minus 4 is add 4, and some sort of pattern is made, right? So for such cases, there's always a pattern made. So then no question is can take more than 2 minutes in exam. If the question is taking more than 2 minutes, so you must be missing something, or you must be doing that wrong, right? So just tick the option which you feel is the closest answer, then move forward. But I told you in first class that never miss any question, because the exam is highly hectic. You might not get the time to just return back to the question. That's why just tick a value at the option and just proceed further. Okay, for this question, you got my point, how I did this?
Like I was doing it in a way that I equate this to the even, like every answer was supposed to be even.
This will much
So
longer. The way you are doing that will take a lot of your time, because you have to check for all of these 4 cases.
Yes. Can you explain the equations? Like I understood till the point where you added and subtracted 4, but can you explain it afterwards, like once more? I did understand the point, but I want to like.
We have 4 equations, right? You got how I made these 4 equations?
Can you repeat it once, please?
Only one, right? Let's do only first one. We have 16a plus 12 is equal to n. If I add 4 and subtract 4, this is 16a plus 16 minus 4 is equal to n, right? I just take 4 to the right, and this will become, and take 16 common. This is 16a plus 1 is equal to n plus 4, right? I just make same pattern for all of these 4 equations, and the right side for all of these is n plus 4. And left side is 16, 24, 24 this, 25 this, and 30 this, right? Just take the LCM of these, because the lowest value must be a multiple of these, right? The LCM of this came out to be 1200, and the right side of all is n plus 4, right? So right side for this will also be n plus 4. So just subtract 4 from the left side. So this will came out to be 1196, which is the lowest possible value of n in this scenario.
Yes, I got it. Thank you.
But how could I understand that I should proceed this way?
You will do that when you start practicing. Start practice as much as you can. Because once you start practice, you can easily identify by just seeing the question that what is a quick approach, how can you make a pattern, and it depends from scenario to scenario. There is no one way to deal the question. There are plenty of ways, which all you have to figure during the exam. There may be some other ways to solve this question, but for me, this is a quickest way to solve this question.
Okay, got you.
Okay, so this was all about the reminders, and